Hi everybody. For me it's very, very cool to be here because there is something magical about the Redis community. People are so supportive, nice, knowledgeable. I don't know if all the programmers are like that. Maybe are we just a very cool species on Earth? Or is something about the Redis community that's special, but it's really touching for me, especially since normally I live in Sicily alone in my house. Then I have this opportunity to join you, and it's from the point of the human contact very touching for me. And also it is where certain ideas that will change the shape of Redis development in the next months. Here it's when this happens, because there is something special about face-to-face communication, and people say, look, I have this use case. Do you understand that? And if we do that, this is much better for me from the point of view of the problem I'm going to solve. So it's great. Thank you very much for being here. And well, today I want to update you about what's coming with Redis 4.0. That should be out in a matter of weeks. And the future of Redis, that's Redis 4.2. That's what we are working to for the next year, basically. Since well, we try to release a new version every 6 months, but apparently it escapes our abilities. It's impossible. So probably it's a matter of waiting 1 year for 4.2, and instead 4.0 is about to be released. To start, Redis 4.0. Well, basically 2 months ago I was ready to release it. I released the first release candidate, and we were perfectly happy with everything. The problem is that Redis was not ready to be released, so we had a disagreement. I talked about with Redis, and it says, no, we need to wait a few months because I don't feel ready. I feel that there is something that you should hack a bit more, please. And so we worked for many months more, and specifically, there was a replication bug. This was a very nice one because, not the bug was a very nasty one, but the interaction between multiple people from different companies in order to fix the same bug. It was one of these conceptual bugs inside the implementation where you don't really know exactly how to address it, because there are multiple possible fixes, but none of them looks like the right solution, but eventually we did that. Another thing that we identified a bit late, and it's going to be fixed soon, is the RDB serialization of modules values. Basically, a module can write its key and its value inside the RDB file when you save your data set. However, if the module is loaded inside Redis, the module knows how to load the value. But if you have an RDB and want to do an offline operation with an RDB tool that parses it, and you encounter a value serialized by a module and the module is not loaded, how do you parse that? Well, the obvious solution would be to have like a prefixed length before the value, so you know, like I have to skip 100 bytes. But the RDB file is conceived in order to be a streaming format, so you never go back. And you don't want also to buffer very huge values and then write them later. But finally we found a solution that's basically to announce with 1 byte every kind of serialization item that the module is serializing. Like what's next is a string, then it's an integer and something like that. And then there is a final byte of end of value. So basically it's possible to parse a module value with zero knowledge about what, you don't know what the pieces are, but you know at least the structure. That could be also future-proof in order to recover data of modules that no longer exist in 10 years, assuming Redis will be still 10 years. I don't know. Then there is the modules thread safe context. This is a very big feature because it's one of Redis 4.0 is a lot more threaded than traditionally Redis was. And this is one of the most interesting threading things that we were able to put. This was one of these features that you say, I don't want to delay to the next version because it's too cool and I want to put it inside in the current version in order to avoid delaying 1 year. But it was quite challenging to implement it, so I will wait a few weeks for feedbacks from my colleague Dvir that is very expert module developer and is trying to implement this new thread safe context in the Redis module. That's a cool open source module for Redis that implements an inverted index. Okay, so let's check what are the big features of 4.0. Of course, there are many minor features, but I want to show you what I believe are going to change the way that people use Redis. In many ways, operational changes that make it less problematic to use, or also use developer-facing features. The first one is psync2. Okay, we have a history of impenetrable names. Beer, Popel, Push, psync2. I don't know why I have this attitude to find strange names, but basically it means partial resynchronization version 2. What is partial resynchronization version 1? It is the idea that when the master and the slave link is broken, the slave can continue when it was left without asking again all the data to perform a full resynchronization. This was the first version, so it was only able to resist replication link breakages. The partial resynchronization version 2 allows to do that across failovers. So we have a slave, the slave gets promoted to master, and the other slaves can continue with the new master without asking for all the data again. And this for failovers is quite cool because before of that, after a failover, you also paid like an availability cost because everybody was doing a bulk synchronization and stuff like that. Now, that's a very interesting improvement. How it works is basically that every possible replication history is tagged with a long tag or perhaps a random tag. And then there is an offset. If an instance has a given tag and a given offset of another one, they are guaranteed to hold exactly the same data. If they have just the same replication tag, it means that they share the history. So if one has a lower offset, it means that it can replicate just getting the data that's missing from an instance with a higher offset. So it's quite cool. Also, this changed completely the implementation of the replication of Redis because in the past it was like when I execute a command, I create the replication stream for that command to materialize in the slave and I send it to the slave. Now the slave can have also other chained slaves connected to it. And it performed again the same operation. Now instead there is a unique replication stream and you pass it all along the way till the final replica in a chain of a chain of a chain. So it changed a lot of code and it's why because we had this conceptual bug. Unlink. Many of you know that Redis is or was mostly single-threaded. Now we are threading it more, but one of the consequences of being single-threaded is that when you execute very fast commands that execute in constant time or in logarithmic time, well, everything is cool. But even when you use just fast commands like that, you can build quite a huge value in a single key. For example, I have a set and I keep adding million elements. At some point, my application logic changes and I want to remove such a key. If I call del key name in order to delete the key, the server blocks because it has to deallocate the memory of millions of elements. So finally, Redis 4.0 introduces a new concept called unlink. What this does is basically to just unlink the value from the data set, but it doesn't really release the value. The value is sent to another thread in order to be reclaimed, the memory to be reclaimed in background in another thread without impacting the main thread. Now, said like that, it sounds very easy, so you could ask, why you didn't that 5 years ago or something like that? The problem is that for this to work, the values of Redis must be completely independent from other values. However, the classical structure that Redis used was that you have a Redis object structure that has a reference counting. So the same value could be shared among different data structures. However, usually the values are not really shared, if not small integers. So this really was not helping much with memory usage. It was just inconvenient in order to perform threading operations. So basically, I took like 1 month to rewrite all the data structures to just use plain strings instead of Redis objects. So less memory. It's now faster because when you access, for example, a set element, instead of going like the key, first cache miss, the value, second cache miss, and then the Redis object structure, third cache miss, and then the string, there is a 1 hop less. And everything is better, and now you can unlink value. The same concept was also extended to the database itself. Do you know the flush all command? That command that it's like the rm-rf of Unix administrators, but for Redis. The face of the operator will be the same with both commands, green. And you can also flush a whole data set in the background. And it's quite cool because at the same time we introduced a new command that's called swapdb. So if you have a given view of your database and you build another one in a new database number, like, you know, the Redis database is the name spacing. In database 0, I build 1 view. Database 1, I build 1 view. Then I use swapdb, and I swap the 2 views with an updated one. And then the old one can be destroyed in the background with flush all async. And that's good news as well. Then there are modules. Okay, modules is like a big chapter, and there will be sessions specifically targeting modules. But what I want to tell now is that modules turned out to be quite different compared to what we thought they were. I started modules thinking that they could be a way to extend Redis, and it certainly is a feature that can replace Lua scripting at a higher level, a more interesting level. But it is especially a framework, so that if you want to add to your Redis servers some kind of operation that has nothing to do actually with Redis. For example, unique ID generations. You use Redis as a platform, so you don't reinvent a new server code, a new protocol, new clients. You just have this framework. You have HA, all the Redis features that are already inside, and that we built actually across years. And you can use it with modules. And you know what's great about modules? They are like a playground for Redis. So it's a huge value in order to experiment with new things. It's like when you go to the sea and you are at the beach, you do things that you'll never do in the hard floor, like trying to walk in your hands or stuff like that. This is modules from the point of view of development. You try new experimental things because it's a self-contained environment where you feel protected. And this is how the safe threaded context started with modules, and they could be then imported into the main Redis core. So what are threaded contexts? I will start with a very simple example. Do you know the keys command of Redis, the one enumerating all the key that you have inside your database? If you have a very large database and you call keys, the instance will block for many seconds and will be a terrible thing. This is Redis mistake 101, everybody calls keys. So normally service providers have this command disabled and stuff like that. Okay, with thread context, you can write a module that implements an unblocking version of keys in like 10 lines of code. And that's cool because when I implemented the features a few weeks ago, and I called the first time the keys command having the latency monitor completely flat, I was smiling at my monitor. Because I'm not used to the possibility that Redis can run this kind of commands performing aggregations without impacting in any way the main thread. And this is just a start because we can do more with key level locking. If you are interested in how it works inside, you can join me in my next deep dive session where I will show the actual code about it. LRAU and LFAU, about strange names. Basically, when you have a Redis instance used as a key, as a cache, you want the old value to expire, the not used value to expire to make space for the new ones. Normally, many caches use an eviction strategy that's called least recently used. Now, the truth about least recently used is that an approximation of something way more cool that's called least frequently used. What you want to evict is not the thing that you used the last, but the thing that you are going probably to use with less probability in the future. But LFU is quite more complex to implement for a number of reasons. But finally, we have it in Redis, and this could be a much more resilient algorithm against different use cases about caching. So we should be good. This is a very big one for operations. Do you know that you can configure Redis with AOF file for append-only operations? However, in the past, the file eventually gets too big, you have to rewrite it. When you rewrite the file, normally it created a new version of the AOF with a sequence of commands. However, RDB, the other serialization format of Redis, is binary, it's more compact, it's faster. It's more efficient than AOF. So what we have now is a mixed format. Basically, when you rewrite the AOF file, you get a preamble. The first part is a RDB file, and then there is a tail of AOF files. And there are more features that are quite exciting but are not big as the ones that I covered. For example, the fragmentation, and there are also Redis cluster improvements. When you have large clusters, now the failure detection happens with less messages and stuff like that. But let's switch to the availability. Well, this time we are very near to release Redis 4.0 as a generally available and stable. It should be like 1 month or something like that. Week less, week more, but that's it. Okay, now let's check what's new in the new version of Redis. And basically, the new version, the developments are focused in 4 different features. Streams, more threading, better Redis cluster, and client-side caching. What are that? Streams is the new data structure of Redis, a new measured data structure of Redis. And it's quite useful in a number of domains where the existing data structures could really not solve the problem well. More threading is the idea that Redis should be more threaded also at other levels, not just the modules, but we want to thread the I/O, the protocol parsing, also the modules should be able to perform key level locking, more threads, because at this point Redis is at a level of maturity, and also the CPUs are with so many cores that it's really important to focus on that feature. And then there is better cluster, because Redis cluster is an incredible hit across our community. Everybody is using Redis cluster. And I discovered that especially when we have such meetings, and all the people ask me questions about Redis cluster, like if there is only Redis cluster that, Redis cluster. So this is the moment where we need to bring more maturity to the tooling of Redis cluster, because the system now works quite well, but it needs to undergo different revisions in order to get more better. Client-side caching. That's a very interesting one. So you have your database that could be directly Redis, or often is another database on disk having a lot of data. And you use your Redis instance for the fast data, or for the caching of the data inside your database. And you also have the clients, and the clients make requests to the Redis or to the database. But why the client itself should not be a smaller, more available, faster cache that's near your application? So it's like CPU that have L3, L2, L1 caches. The same should happen in our applications, basically. Now, there are already clients that implement client-side caching. But what about receiving a bit of help from the Redis server itself? Because the problem when you have cached values inside your application is the invalidation, because the server can get those changes in those keys, and who is going to notify the client about that? The idea is to build a specific features of Redis that helps the client to invalidate the values. Then there is this queue. You may know this queue. It's one of the a new open source project that I published 1 year ago. It's a message queue with interesting properties. It's AP, guaranteed delivery. It works magically. It's quite cool. It's in memory. It's an in-memory message broker, basically. This queue was quite an interesting project, but what I had to do in order to create it is to take Redis, remove Redis from Redis to just get the protocol, the serialization format, the data structure that I needed to use for this queue, and then implement these queues inside. This means that there was a huge code duplication between the Redis server and this queue. And eventually I was not able to synchronize them because it was too time consuming. At the same time, we introduced the Redis modules. And well, I said probably it's time for us to rewrite this queue in terms of Redis modules. But to do so, we need a module cluster API. And that will be very interesting in my opinion, because this will make Redis a framework for distributed systems. It means that you can just take Redis, load modules, and implement new distributed systems that are completely not like Redis itself. You can implement an eventually consistent store, you can implement a message broker, you can implement, I don't know, like distributed counters, whatever you want. And so this is quite challenging, but I hope we will be able to do that. Out of all these features, I want to zoom a little bit on the new data structure, the streams. The streams are not a made-up data structure, but it was generated by a specific need. And the need was basically time series. That's a big one in IoT, and in general, Redis is quite used for this kind of use cases, and the multiple consumer problems. What's the multiple consumers problems? Think at the new Redis communication data structures are the blocking lists and the pub sub. Pub sub is fire and forget. So you can have multiple consumers of the same messages, but if a consumer is disconnected, message is lost. The lists are durable, but are one message, one receiver. It's not one message, multiple receivers. There is no fan out. In some way, you can kind of do that with sorted set. However, sorted set are optimized in order to have elements that move when you change the score. Also, they don't support unique elements because they are sets. So if you have a reading in a time series and you have 2 times the same reading, you have to find hacks in order for the elements to be distinguished, like to prepend a Unix timestamp or something like that. But in general, it was an abuse of the sorted set data structure. It was not a great fit. And also, they consume a lot of memory because they do great things that you don't need in time series and in streaming. PubSub is not a data structure, so it's really a different thing. It's fire and forget. And to add to PubSub storage, that was a potential fix, was like an hack. No, it was not a well-designed solution, in my opinion. Lists are great for messaging, but as I said, they are good for things that are put inside and come outside to single clients, and also they are impenetrable in the middle, because it's O, the N, so they are basically linear time access data structures. Totally not what you want with time series. If you have like many appliances recording the temperature, you want to ask like in the 1st of June, what was the temperature between 5 p.m. and 6 p.m. So you want to access in the middle. Streams from the point of view of abstract data types are logs. What is a log file? It has certain obvious properties. It's 1 entry per line. It's ordered. The next entry will be put at the end of the file. And every entry has an offset in a log file. Repeated entries are okay. And log files are extremely memory efficient. What's the idea is to take the log file, the concept of log file that every programmer has in his or her mind, and transform that in an abstract idea. And how you abstract a log file? Entries are hashes, so they are structured. For example, you have client ID, temperature, and humidity. You have different fields. You have logical offset, so after an entry is added, you get an offset, and this will be the entry offset forever. And the offset is bound to the time the entry was added. Also, you want basically to be able to access random ranges and to throw away all data, because most of the times, for example, you want to just retain 1 week of history in a time season and go away with all this old stuff. And they must be memory efficient. So what we did was to take the concept of the log file, split it in many parts, and then we split it in many parts because large blobs containing multiple entries are very memory efficient. There are no pointer inside. And then you take a radix tree and use a radix tree in order to index these pieces. And this mixed data structure is quite memory efficient, is fast, it's quite cool. And this is how the API looks like. So you append a new entry in a given key that contains a string, and you get a unique ID that contains the millisecond Unix stamp and a counter that is a progressive counter about the entry ID in that specific millisecond. And the streaming API is quite full-featured. It contains both Kafka features like consumer groups, and also you can take range, have blocking API. You say, for example, give me only entries that have this ID or greater than that, and stuff like that. Well, I hope that this gave you the idea, and however, if you are interested in the implementation details of all the things we talked about, please come to attend my next talks, where we will check the actual code and not just the higher layer. Thank you.